Okay friends, so far we have seen in our previous video, we have seen the magnetism. What is the magnetism? We saw also the magnetic, what is magnetic axis, what is end on side, what is broad side on. Then we saw earth magnetism. In earth magnetism we saw transient change and secular changes, and how the earth magnetism influence our magnetic compass. Thereafter we saw ship's magnetism. In ship's magnetism we saw permanent magnet. So permanent magnet, there was two components, so horizontal component and vertical component. So horizontal component was force O and vertical component was force R. So this horizontal component was subdivided in two forces, the horizontal fore and aft component, and the one is athwartship component. The fore and aft component was force P, athwartship was force Q. So now we have seen force P, force Q, force R. Thereafter we saw induced magnetic field. So few terminology we have already seen, like what is imaginary rod, which all 9 imaginary rod we will see later also, and what is effective pole, what is further pole, and then we saw 3 set of that imaginary rod, that is A, B, C, D, E, F and G, H, K. What is this? We will see one by one in detail. So the one which I have already drawn on board is very important point for the induced magnetism. So this table we can say is the backbone of the induced magnetism, in which if you manage to understand this thing, then this magnetic compass is very easy. Otherwise it will be tough and you cannot understand anyhow. So what is this? This A, B, C, D, E, F and G, H, K. There are 9 rod. We imagine that this type of rod means the type of ferromagnetic material or iron rod which is present on our ship and which influence the magnetic compass in any form. So we'll see one by one which how does it align on ship near the compass and how does it affect our compass. So but here we'll try to understand this table, and this table I will suggest you to just make this table as it is in your notebook, so that later on you can refer this for your reference. So what this is induced magnetism. Induced magnetism we have already seen. This is the horizontal component and vertical component. In horizontal component there are two, that it is horizontal, like if it is in fore and aft direction, then it is fore and aft, and one is athwartship, it is in port and starboard, and one is vertical component. So now these all 3 set has been divided in three sets. So first set A, B, C, second D, E, F, G, H, K. What is this? We'll see. So A, B, C, wherever you see the rod A, B or C, what is that? So if you see, I have written A in the column of fore and aft, B in the column of athwartship and C in the column of vertical. Same way D, E, F in A, D, G all in fore and aft, athwartship B, E and H, and then vertical C, F and K. What is that? That we'll see. After this I will draw all these 9 rods, and there it will be more clear. But for now you just have to compare this thing. We have to compare this rod with what I have written here. So what is here? The effective pole, which we have already discussed in previous part. The effective pole in level, this is the key point, in level with compass. Like suppose if our vessel is here, our vessel or our compass is here, so the effective pole of that rod, suppose I talk about this rod A, which is fore and aft. So in level, which means if your compass is here, then that rod must be passing through to in level, that rod must be in level with this compass, and on fore and aft line through the compass. In fore and aft line, like suppose one rod is here, it is fore and aft in the same level, another might be here. So in level and in fore and aft line through the compass. So this is for A. If it is related to B, like athwartship, then it might be somewhat like this. It is in level. This is also a rod which is in athwartship of this compass. If it is, say, we talk about vertical, then might be like suppose your ship is like this. Here it is compass. So it might be either here or here. So the all rod we'll see later. After this table I will make that table. So you just have to keep remember the effective pole in level with compass and on fore and aft line through the compass. So for second set D, E and F, the effective pole in level, again in level with compass and on athwartship line. So what is the athwartship line? Like D is fore and aft, but in athwartship, it is in level but not exactly in the line with the compass. It might be somewhere here, might be somewhere here. And for E, it might be somewhere here, might be somewhere here. F, it might be somewhere here, might be somewhere here. So the effective pole, we are only talking about effective pole. So whichever the nearest one, that will become effective. That will become effective. These all are effective pole. Now it will be more clear when I draw the next table. So for now, you just have to keep this one in your mind. So G, H and K, this is the third set. The effective pole on vertical line through the compass. So I'll just draw this one and then we'll see. So this table is very important and you keep this one always in reference till the time you would remember this while you are studying this magnetic compass. So just I will draw that table and we'll see how this all 9 rods looks like. Yeah, so before we draw that 9 rod, we see the sign convention for SI rod, how the sign we need to show for that rod. So I have written here, the effective pole is considered positive. If effective pole means the nearest one is considered positive if it is forward of, or starboard side of, or below of compass. The point here is compass. So if it is forward of the compass, or starboard side of the compass, or below the compass, that time we'll consider the effective pole is positive. Same thing will become negative if it is aft of, port side of, and above of compass. So it will become negative, otherwise it is positive. Same, it was for effective pole. Now for further pole is considered positive. If it is forward of, or starboard of, or below the effective pole, not the compass, but reference point is effective pole. Here the reference point is compass. So, and same will be considered as negative if it is aft of, or port side of, or above the effective pole. Same way, rod is considered positive if both the poles of the rod are of same sign. If both, like suppose positive, one is positive, another one is positive, then the rod will be considered as positive. If effective pole is negative and further pole is negative, then it will be considered as positive, because both are same. If any one, either further or effective, any one is different than the other, then that time it will be considered as negative if different sign. So just to understand this, what is this, we'll draw one thing and we'll see. Yeah, so it is just I have drawn here. This is the deck of that Monkey Island, and here is a compass, and these are the different rod. This rod will be more clear when I will draw the next table of that all 9 rod. So for now, just for the sign convention, we'll see how they sign. Like suppose this fore and aft, like your vessel is support, this is the forward part of your vessel, this is the aft part of your vessel, and this is the compass, and compass is indicating somewhere in the forward by this arrow. Like suppose this one, if this one is positive for a time, if you take this one is positive, so for this rod, this is forward of the compass, and the effective pole is forward of the compass, then it will become positive, and this is the further pole of that. So further pole is further forward of this effective pole, which we have just written before this. The further pole is forward of this effective pole, so this one is also become positive. And again, now you see this now about this, and this rod is called as rod A, will be, it will more clear. So both are positive, so this rod will become plus A. Now we talk about this rod, the one which is vertical. So this rod is effective pole is forward of the compass, so this one will become positive, and the further pole is below the effective pole, so this one also become positive, so this will become plus C. This is plus C rod. Now for this one we come through, see here, the effective pole is this one, because this is near to the compass, so this is below the compass, so this one become positive, and the further pole is further below the effective pole, so this one also become positive. So this is actually, it is K rod, K, we'll see later. So this one become plus K. Now for this rod, the effective pole is here, because this is near to the compass, so this is below the compass, so it will become positive, and the further pole is forward of the this effective pole, so this one also become positive, so this become rod G. So this is how the sign convention is denoted with respect to the end of this effective pole or further pole, or where this particular rod is located with reference to the compass. Now we'll see that 9 rod, and thereafter we'll see further. So this is the 9 rod which I have already drawn on the board, and one by one we'll see all. So for plus A, we have already talked, the A, B, C is, the A1 is fore and aft. So this is the fore and aft rod, this one is fore and aft, this one is fore and aft, this is fore and aft. So for here, if you see this rod, the effective pole, because this is the compass, this is compass, so if it is compass, the nearest one is effective, so nearest is forward of the compass, so it is become positive, and the further pole is further forward of this effective pole, so this one also become positive, so both positive. Now we'll talk about this aft one. So the nearest pole, which is effective pole, is aft of the compass, so this is negative, and the further pole is further aft of the effective pole, so this is also negative, so both are same sign, so it will become plus A. Again for the second one, suppose one continuous rod is there which is passing through the compass, so the effective pole which is aft of the compass, that's why this one become negative, the effective pole, because this is near to the compass, and the other one, the farther pole, is forward of the effective pole, so this one become positive. So this positive, this one negative, so this will become minus A. Same way for plus B, this is the effective pole, this one is effective pole, and for B is outward shift, horizontal component. So all the rod is in outward shift direction. So the effective pole of this rod is this one. So this is forward of the compass, so this is positive, and this is starboard side of this effective pole, so this is become positive. For this rod, this is aft of the compass, so this one become negative, and the further pole is further port side of the effective pole, so this is also negative. So both positive, positive, negative, negative, so this one become plus B. Same way here, this one is forward, so plus, and this is port, so minus. This one is aft, so minus, and this is starboard of the effective, so plus. So both are different, so minus B. Here for C, see the vertical component. So in vertical component, you see this is the your compass. So suppose one vertical rod is somewhere here. So this is forward of the effective pole, so this is positive, and the further pole is below the effective pole, so this is also positive. So both positive. Here in this rod, this is aft of the compass, so negative, and the other further pole is further above the effective pole, so this is also negative. So both are same. So this one become plus C. The same way, this is just opposite of that, so it will become minus C. Again for D, E, and F. So D is fore and aft rod, but it is in level of the compass, but not in the same fore and aft. It is somewhat in outward shift direction. So it is not in the same direction, but in outward shift direction. So this is effective pole of that rod. So this is starboard side of this compass, so positive, and the further pole is forward of this effective pole, so this is also positive. So both positive. Same way here, both negative. So this one become plus D. In the same opposite of that, it is port side of this one, so negative, forward, so positive. So this one is on the starboard side, so positive, and the further pole is aft of the effective pole, so negative. Both are different, so minus. So here for E, suppose one rod is here, one is here. So for this rod, the effective pole is starboard side of the compass, so plus, and the further pole is further starboard of the compass, so plus. Here this one is port side of the compass, so negative, and the further pole is further port of the effective pole, so negative. So both same side, so minus plus E. Here suppose one continuous rod is there which is passing through the compass, so the starboard one will become positive and port one will become negative. So both are different, so it will become minus E. In this one, you will see yeah, okay, for D, E, and F also, the D is fore and aft line, E is outward shift direction, and F is vertical. So for here, in this direction, we were seeing this rod either forward of or aft of. Here we are seeing from the aft of the vessel, so it is either starboard of, that's why I have written here port and starboard. So it is either port or starboard. So for this rod, this is port side of the compass, so this end is the effective end, it is port side, so negative, and the other one is further above the effective port, so this is also negative. For this one is effective one is on the starboard side, so positive, and the further is further below, so it's also positive, that's why it become plus F. And again for this one, it is just opposite of this, so it become minus F. Here for GHK, in GHK it is in fore and aft line, so the vessel I have shown here the picture in fore and aft direction for G. So suppose this is also in the line, but not exactly in the line, it is either above or below, so it is above. So if your compass is here and it is above your compass, so above is negative, and the further pole is further below, further aft of the effective pole, so this is also negative. And for this rod, this is below the compass, so it is positive, and the further end is further forward of this effective pole, so this is also positive. Both are positive, so plus G. For this one, again the opposite of this, because this is above, so negative, this is forward of this, so positive, this is below, so positive, this is aft though, so negative, so this one become minus G. For this one, now here we are showing because you have to show outward shift, that's why I am showing the picture from the which is view from the stern, and that's why I have draw the propeller here. So this is port, this is starboard, and this is outward shift direction rod. So suppose this is above the because this end effective end is above the compass, so negative, and this is for the port of that, so negative. Here it is below, so positive, this is for the starboard, so positive. Both are same sign, so this one become GH, so plus H. Here you can see just opposite of this, so this is different, so this will become minus H. Here because K is vertical rod, so I have shown the picture from the stern, that's why the propeller is shown here. This is port, this is starboard, so one rod which is below the compass, so this is the effective one, so effective is below the compass, so positive, and the further pole is further below, so this is also positive, and this one is above the compass, so negative, and the further pole is further above, so it is also negative. So both are same, so it is plus K, oh sorry, yeah, minus K, minus H, okay. And here since suppose one continuous rod is there, so the below one is positive, above one is negative, so both are different, so minus K. So these are the 9 rods which you have to recognize anywhere if it is given in your whole chapter anywhere. So, but only few rods are important, because like see minus C rod, because funnel is there, so this is effective. Actually this is applicable on board, because on this rod there is funnel. So this one we have to study. Again, a few more rods are there which are actually exist on board. So those are the rod which we'll study in detail, and the rest are just for the knowledge. So we'll go one by one, and now we'll see what is well sighted compass. We'll see in the next. Now we'll see what is the well sighted compass. So what is well sighted compass? Means if a vessel which is constructed symmetrical about fore and aft center line, means whatever the all the construction whatever is on the port side of the center line, the same construction is there on the starboard side of the center line. That vessel is called a symmetric construction. So, and compass, magnetic compass is installed on fore and aft center line. If the magnetic compass is exactly situated or installed on the fore and aft center line and vessel is symmetrical, in that condition it will be said as vessel is well sighted. And then if it is well sighted, then there will be very less cause of deviation because of various, because whatever is on one side of the compass, that will be cancelled out by the other side of the same construction. Now we need to know that there are very various type of rods are available, and those all rod will influence the compass. So these will produce some deviation to the compass needle. So what all the you see the sine curves are there, the cos curves are there. So all these curve is actually giving a perfect value, actual value of a particular curve at a particular angle. What is the value? So we can find out from there. But because there are various type of deviation, so it is required to know what is the actual, what is the total deviation of a compass due to the various factor, due to the various rod which we have already discussed. So one scientist was a French scientist named James Fourier. He given a formula from the mathematical series. A mathematical series is for it is called as Fourier series formula. It is a mathematical tool that actually break down the periodic function to a combination of sine and cosine wave, and he given a formula, and with this formula we can calculate the total deviation of our compass. So here nothing to worry, to just to see that it's a very difficult or something, or I have made a very typical diagram over here. So it is just for easy mapping. That's why it is nothing, just you need to understand, and thereafter it will be easy. So whatever is given, but for that deviation any course, but the condition is vessel is in upright condition, then only this formula is applicable. So he has given a formula that is A plus B sine cos plus C cos cos plus D sine 2 cos plus E cos 2 cos. Again you can, if you want, you can proceed it further to the again it will become now F sine 3 cos plus G cos 3 cos, like this, so on. So as long as you go, you can proceed this formula. That's why it is just a series of the Fourier series formula. So what is that? With that A is a constant value. We'll just study later about each and every constant like A, B, C, D and E. Everything what is that we'll study one by one, and that is actually the chapter is. So this A is called constant, and B plus sine cos plus C plus cos cos, this is called semicircular, and this one because of 2 cos it is called quadrant. Now what is this A? It is a constant, and in this one there are two type of this constant is real A or apparent A. Real A is because of B and D rod of different sign, and apparent A is it is not because of the rod, it is something different than the ship's magnetic field. What is this? Because B is further divided into one. So permanent B and induced B. So permanent B is because of force P, and this induced is because of C rod, like our funnel. And then again for C is C also here, permanent C and induced C. Then permanent C is because of force Q, and this induced C is because of F rod. Again D is because of E rod, E is because of B and D rod of same name. So it is similar to A, real A, but here it is same sign, here it is different sign. Now we'll see one by one what is coefficient. First we'll start with the coefficient. What is coefficient and how we can remember the sign and how to split this. I'll just make a diagram and then we'll proceed. Yeah, now we'll see what is coefficient. Like in our previous formula we saw A plus B sine cos plus C cos cos plus D sine 2 cos plus E cos 2 cos. So A, B, C, D, what is that? Those are all coefficient. So for just for a definition, if you can if you want write, just the maximum value of deviation due to the compass, which due to the component which they represent. Example may B cos cos, and or C cos course, B sin course, C cos course, or D sin 2 course, etc. Whatever. Now for the sign conversion, I will just point out one thing, one thumb rule, and that will be applicable everywhere. So it is required you need to focus here. Wherever, if you see in any quadrant, if you see, just start from 001 degree, 001 degree till, like suppose this is 90 degree, so it is something 45 degree, so up to 044 degree, from 001 to 044 degree. If it is east in that one, if it is showing east, then it will become plus A. Or if from 001 to 044 degree, if it is showing anything negative or anything west, then in that case it will become minus. It will become minus. So if it is circular, then it is plus A, which I already told you that because in our previous that formula, that A is constant, means it is constant throughout, so it is circular. So if it is a circular totally, means in all direction it is only one east, then it is plus A, or it is totally west, then it is minus A. But in all direction 360 degree, here also in 360 degree. But in B, because I told you that time that B is semicircular, so it is semicircular, either this half or this half. So you start from 001 degree till 044 degree. If it is east in this one, if it is east, then it will be plus B. If it is west, then minus B in that quadrant. C is also, so B sine course plus C cos course, it is semicircular. So this semicircular has divided in port and starboard side, and this one C is divided in upper and lower part. So just C 001 degree to 044 degree. If it is east, then plus C. If it is west, then minus C. Now D and E is quadrantal, so means there are 4 parts. So just see if 001 degree till 044 degree, if it is east, then plus D. If it is west, then minus D. Again for E, you see the same thing. If it is plus east, then plus. If it is west, then minus. Now we have seen how we can find out the sign of any particular coefficient. Now we need to know how we can give after this we'll study about each and every coefficient A, B, C, D and E. So before that, we'll see how we'll study all those coefficients. So each of that coefficient will be studied in 5 points. So what are those 5 points, we'll discuss now, and thereafter we'll start one by one all the coefficients. So these are the 5 points as below for the coefficient. So each coefficient will be studied in these 5 points. So first of all, we'll see the definition, because we are study the same for the written exam also. So definition is required. Then we'll see what is the cause of that particular coefficient and what is the nature of that coefficient. Then we'll see change in deviation due to change in course, like when our vessel is going in particular course, and when we are changing, where vessel is changing its heading or course, then how will it change the deviation, what will the how will it affect the deviation. So that we'll see. And then change in deviation due to change in position, like suppose you are at equator and now we are going to the particular latitude on the north side or on the south side. So how will affect, how will it change? So we'll see in the respect to the latitude or the hemisphere, either you are going from the southern hemisphere to northern hemisphere, or from northern to southern. So effect in on directive force. Here is the important point is directive force. What is directive force? So directive force is nothing but a field extended towards magnetic north. Like suppose if it is north and this is east, west, south, your needle is somewhere, your compass is showing a heading somewhere, like suppose here it is constant, suppose, and suppose something is there which is creating a blue pole over here. So as per now your directive force, it is showing somewhere, it is how much it is towards the north, so it is showing a directive force. Now the thing is, suppose because of this blue pole, and as I have already told you, we will study for the red pole of that. So this blue pole will attract this this red, and your new direction of this force will be somewhere here. So it is increasing, like it was earlier it was little bit on easterly, but now it is coming to the towards the north. So it is coming towards the north, so means your field extent is increasing towards the north, so the directive force is increasing here. Suppose this blue point is, instead of this, it is somewhere here on this side. So what will happen, then your this arrow will go somewhere here, your needle will deviate from this position and it will go somewhere from away from the north. So your directive force will be said as it is decreasing. So this is what is directive force, means how much the strength of that field is increasing toward the magnetic north. So if it is increasing, if it is going toward the north, means your directive force is increasing. If it is going away or toward the south, then it is decreasing. And after this all, we'll see the correction, means how we can correct that particular coefficient or that particular error, which type of corrector we need to use, or which type of correction is being used on board. So that now we'll start with the real coefficient A, and we'll go one by one to the other. Now we'll see real coefficient A, which is caused by real coefficient A. In this one, we have plus real coefficient A and minus real coefficient A. So plus real coefficient A will form because of minus B and plus D rod, and minus real coefficient A will just opposite of that, plus B and minus D rod. So for your exam purpose, if definition you require, I'll just dictate the definition. You can write, or you can just switch on the CC mode of your YouTube, and from there you can just copy. For now, just I will dictate the definition. So what is real coefficient A? It is a constant value of deviation which remains same in sign and magnitude for all direction of ship's head. It is caused by induced magnetism in unsymmetrical pair of horizontal soft iron around the compass. In terms of rod, real coefficient A is caused by B and D rod of different sign but of same value, different sign but of same value. Minus B and plus D rod cause plus real coefficient A, whereas plus B and minus D rod cause minus real coefficient A. So now here we will see the real coefficient A, and I have already told you the sign convention for A, B, C, and where I told you that we have to see from 001 to 044 degree. If it is east, then it will be east, deviation will be east. So this is the perfect example of that. That's why I have written here east. Now we'll see here, like suppose magnetic line of force are coming from south, like it is coming from here. That's why I have drawn here this arrow mark. So how will it affect these all rod? So for this is the first time, that's why I am explaining this. So suppose this is magnetic line of force is coming. So for this vertical rod, one vertical rod is here. So because the magnetic line of force where it entering is the blue pole, so for this rod it will become blue over here. So if this end become blue, so opposite will become red. Here I did not show anything because it is broadside on. So even if you place this one in the exact because it is broadside on, in the direction of this, it will not get induced. This rod will not get induced, so it will remain neutral here. So only this rod will get affected. Here in this one, this end is near to the magnetic line of force, so this end will become blue and the other one become red. So for this rod also it will become blue at this end and the red at this end. Here, since this is broad on side, so it will not get induced. And here in this one, it is the nearest one will become blue and the other one become red. In this one also, here it will become blue, this end will become blue and the other one become red. So this one is also near to this magnetic line of force, so this end will become blue, the other one become red. Here this one become blue, other red, and this one will, there will be no effect because this is broadside on. Here this one blue, red, blue, red, blue, red, no effect, blue, red, blue, red. So now how will it deviate our this needle? So I have already told you, we will only consider the red point of the compass needle. So now see, the red compass of this needle is here. Suppose your this compass is here, so this is neutral, so it will not affect anymore. But this is blue, so what will happen? This one will attract this needle towards itself. So your needle will deviate somewhere here. So how is it deviating? It is easterly. It is because it was somewhere here in the 4.5 line. But because of this induction, because this is blue and the red end of needle, it will deviate towards this blue. So this deviation will be perfectly like this. So the deviation is east. Now in this one, suppose here it is blue. So this one will try this. Suppose your needle is red and this is blue. So it will try to attract here, and this blue will try to attract here. So the resultant will be somewhere here. So the deviation is finally easterly. Here the blue end is here and the red end of your needle is here. So this one will attract itself towards it. So it is deviation is again east. So deviation is easterly. If you see here, this blue end is here, so it will try to attract here, and this red end, this because the red end is here and red is here, so it will try to repel it. So if it repel it, so the one component is here, other component is here, so resultant will be somewhere here. So the deviation is easterly. It is going easterly. Here this red end is here and this is neutral. So suppose this is the this is your initial condition. So what will happen? How this red end will affect? this red end will pull, repel, so your needle will deflect towards the east, so deviation is easterly. In this one, this red end will repel, this end will repel, so the deviation will be somewhere here, so this is also easterly. In this one, this red end will deviate this one, so it is easterly. Here this red end will deviate here, repel here, and this blue will attract towards it, so these two components, so resultant of this will become this, so easterly. So you can see at every coordinate, either at the coordinate cardinal mark or at the intercardinal mark, everywhere the deviation is east, that's why it is east. And one question is being asked there about the easterly bias, so this is the real coefficient A, it is easterly bias, because of this magnetic line of force, the deviation of your needle is at every cardinal and intercardinal mark is easterly, so everywhere it is deviating your needle towards east, and this is a easterly bias. So this is about the real coefficient A. And now I hope you understand what I was talking there about east and what is the deviation, and this is all about the real coefficient A plus A. Now we'll see, so easterly, so everywhere it is east, so it is plus A. And this is what is this minus B and plus D, so this is minus B rod and this is plus D rod. I have already seen in that 9 rod diagram, so you can find out from there. And in the next part, this part is going to be large, so I will just stop this part here only, and from next part we'll see what is the minus A real coefficient. We'll see with the same diagram and for few more coefficients, so that it will be very easy and clear for you to understand, and thereafter we'll see for the other coefficient like B, C, D and E. So this is here only I will stop this part 3 of my magnetic compass, and hereafter we will start in the next part. So this is all about real coefficient A. Thank you for watching this video, and just wait for the next video. Thank you.